Welcome back, Mustangs. We're back here again with another edition of how to do problems that deal with exponent rules. Like my little sparkly hat, that's compliments of Mr. Mott. Don't let him tell you he doesn't have these fun, cool things. Um, Anyways, so today we're doing the second day of notes, and let's review the rules first before we actually get moving with this. Okay. So when there's three rules that we need to remember, technically four if you include the zero power rule. But with this one, when we're talking about multiplication, remember that the rule was you take the exponents and you're going to add those two together. So when we have a 10 and a 3 in this, we got a 10 and a 3 going on here. Remember that this 10 implies that we have x 10 separate times. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that when we look at the x to the third, we have three x's here. So when we look at the total of these, we're just going to combine those, and it's going to be 10 plus that 3. So there's going to be a total of 13 x's. That's when we're adding the exponents together. All right. With the division rule, recall that what we're doing is subtraction. And again, that's because that whole battle that takes place between the top and the bottom. So when we say that we've got 15 x's here, remember that says that we've got 1, 2, 3, 4, 5, so on and so forth. There's 15 of those. And then on the bottom, we've got 10 of them. So 1, 2, 3, 4, 5, and there's 10 of them. And what's happening is, remember that each one of them is eliminating the other one. So when we look at an x on the top along with an x on the bottom, remember that anything divided by itself is simply going to equal 1. So what we're doing is we're just canceling that out. Cancel one of these, cancel one of these, cancel one of these, cancel one of these, and we're just going to keep canceling. Well, canceling is the same as subtraction. So if you remember, what we're going to do is we're going to take that 15 that's right there, and we're going to take the 10 that's right here, and we're going to simply just subtract them. Who has more, they're going to win the battle, right? So if there's 15 on the top, take away the 10, we are going to be left with a total of just 5. Excuse me, 5. All right? So x to the 5th power there. The power rule says that, if you recall, you have to take the 4 and distribute it to everything. Now, what I saw last time was that most people are doing a really great job distributing it. That 4 is going to absolutely everything, right? The thing that most people are messing up on this, though, is they're forgetting that this 3 is actually here, and that 4 is actually going to go to that 3 as well. Not just to the variables, it goes to everything that's inside the parentheses. So if we were to write this out, you're supposed to have that 3 with a 4 put on there. And then that x to the 4th is going to be to the 4th power as well. And that y to the 2nd is going to be to the 4th power as well. Okay, so that 4 is getting distributed to every single thing in there. That 4 is going to go to all 3 parts to what's inside there. Just simplify from here. This is 81. This will be x to the 16th, and this will be y to the 8th when you multiply them together. All right. So using these rules, what we're going to try to do is work through these 8 problems here. All right, and we're just going to go bit by bit. So when we're doing these, the multiplication of these, we're taking the parts that go together and we're putting them together. Okay. There's no powers. Okay, I should back up. Sorry. So when we're doing these, if there's ever a power outside of our problem, so if there's parentheses and there's a power outside, take that power and distribute it first. If there's nothing outside, there's nothing to do there. It's real easy from that point. So when we look at this, there's nothing outside, so there's no power in the exponents here, so we don't have to worry about a power raised to a power, so now we're just multiplying. So let's put things together that go together. These two are going to go together. We're going to have 10 times negative 8. Then we're going to look at the k's. The k's, there's 5 here and there's 7 here. So there's a total of k5 and times k7. Put these together, we're going to end up with negative 80 and then 12 k's. And then our final answer is just negative 80 k to the 12th. Okay. Let's look at the next one here. So now we've got a fraction going on. There's 2 separate problems. There's no distribution. We don't have any parentheses. There's no distribution going on. So if we were to look at these as like 2 separate problems, we've got problem number 1, which is 25 over 30. And then problem number 2, which is the x to the 7 over x to the 2nd. Okay, those are separate things going on there. on your calculators, okay, if you recall, on your decimals calculator, you could take and reduce fractions on there, okay? So if I wanted to reduce 25 over 30, I would just go 25 divided by 30. And recall that 25 over 30 gives us a fraction there, but it gives us as the decimal. Now I'm going to move so that I'm actually pointing here. That little spot right there on your screen, okay, that little point right there on decimals, that's the button that we use for converting things back into fractions. So we're going to use that, and that's going to be just simply 5 over 6, okay? So going back and reducing 25 over 30, we now know that that's going to equal 5 over 6. Now with this, we have x to the 7th over x to the 2nd. Remember, this is a subtraction situation. We're going to simply do 7 minus 2. And think about, where is there more? There's more on the top than there are on the bottom. And so the top is going to win this battle. That's where those 5 are going to stay, at the top. There's still 5 on the top. Okay, that's it. That's your whole answer. 5 over 6 and x to the 5th on the top. Next one. There's nothing outside of my parentheses here, so there's no power to distribute. So we're just combining things at this point, all right? Let's start first with the 7 and the negative 3. So that's going to be 7 times negative 3, which is negative 21. The next thing, we're going to have a to the 4th and an a. Now remember, this a, because I see it, it's there. We know that there's one of them, all right? So we can put a 1 there. So there's a to the 4th and a to the 1st. There are a total of a to the 5th. All right, move on to the next thing. We get b to the 2 and b to the 3. There is a total of b2 and b3, so there's a total of b to the 5th. That's your entire answer right there. Now, I'm separating it a little bit just so that you can kind of see that they're really separate problems, but the actual answer is supposed to be just really close. It's just 21, a to the 5th, b to the 5th. Okay? All right, let's move on to number 4. Just a heads up, I might be getting a visitor here in a second. Somebody left their phone in the class. All right, one problem at a time here. We've got 21 over 16. And then we've got a to the 9th and a to the 2nd. And then we got b to the 10th. And then recall, because I see it there, it exists, there's one of them. So we got b to the 1st. Sorry, I wanted to change the colors there. Give me one sec. That's b to the 10th and b to the 1st. So let's take our fractions and reduce them if they can be reduced. So 21 over 16, we're going to go back over to decimals here. 21 divided by 16. Reduce it. It stays 21 over 16. Can't do anything with it. So what we're going to do is just go ahead and leave it as a 21 over 16. With my a's, 9 minus 2 means we end up with 7. And with my b's, 10 minus 1, it means that we're going to have b to the 9th. And there's your entire answer. Okay? With problem 5, we've actually got a number on the outside of my parentheses here. So that number outside is a power raised to power. We have to distribute that to everything that's inside of this problem. Okay? So once we distribute that, we're going to have a 4 raised to the 4th power. We're going to have an x to the 2nd raised to the 4th power. And then we're going to have a y to the 3rd raised to the 4th power. So again, that 4 is going to all 3 parts of what's inside of my expression there. 4 to the 4th power, you can throw that into your calculator. We get 256. Whoops. We get 256. For the x's, we get x to the 8th power. And for the y's, we get y to the 12th. Again, that's 3 times 4. And for the other one, it's 2 times 4. Okay? And that's our final answer. Nothing else we could do. Take a look at number 6. All right? And we got to take a second and talk about this one because there's something that's wonky that's going to happen. So that 3, because we have a number on the outside, that 3 is going to be distributed to everything that's inside of my problem here. Okay? So let's take that 3 and distribute it to all parts that are inside there. So my first part is going to be a negative 5 to the 3rd. Now I'm going to put a star by this because that's the thing that we have to talk about. We're going to have an a to the 3rd to the 3rd. we're going to have a b to the fourth to the third, and then we have a c to the first to the third. Remember, there's a 1 right here since it's not written. Okay? Do the easy stuff first. This will be a to the ninth. Remember, it's just 3 times 3, so just a to the ninth. Let me write that better. My numbers and letters look the same. A to the ninth. And then for the b's that are going on here, we've got b to the 3 times 4, which is going to be 12. And then for the c's, we've got c to the 1 times 3, which is 3. Now I want to talk about this -5 to the third power. There's 2 ways that people generally write these things in the calculator, okay? There's a correct way, and then there's the wrong way, okay? The correct way is doing -5 to the third power. Because it's in the parentheses when we look at this, you have to keep it in the parentheses when we put it in the calculator. What people do is they take it and they put it as -5 to the third. Now I'm going to show you why this is different. Okay, we've got -5 raised to the third, and then we've got parentheses -5 raised to the third. Okay, so one of these, and in this case it doesn't make a difference because of the fact that it ends up being a negative overall. But what ends up happening is one of these answers, so this -5 over 3, what the calculator is reading it as is the opposite of 5 to the third, versus the second one, which is saying -5 to the third power. So if this had been a 2 in here, let's see what happens if I put a 2 instead. -5 to the second, and then -5 to the second. They look like they should be the same, but look at my answers. One of them gives a positive, one of them gives a negative. Be right back. Phone. There you go. You're welcome. All right, sorry, we're back. So one of them gives a positive, one of them gives a negative, and the parentheses make a difference for this. Okay, so just always use parentheses when you're raising it to a power. And for this answer, again, we get -125. For the overall answer, it would be this whole monstrosity right here. Okay? All right, 2 more. All right, we've got a power on the outside. So that power on the outside is going to be distributed to absolutely everything on the inside. Everything. All right? So let's make this look like that power is applied to everything. That 2 is going to get that power. That x is going to get that power. The 3 is going to get that power. That y to the 5th is going to get that power. Every single thing in this got that power applied to it. Everything. Okay? So now let's go ahead and simplify from here. That 2 to the 4th is going to equal 16. That 3 to the 4th is going to equal 81. The x to the 4th is just going to be x to the 4th. And the y to the, again, it's 5 times 4, so this will be y to the 20th. Now the x's and y's are not going to cancel out. You don't cancel x's and y's because they're not the same. But the 16 and 18, let's see if we can reduce that fraction. So let's go back over here and I'm going to clear out some of these. Let's take 16 and 18 and let's see if those reduce. Nope, 81, sorry, 81. And hit the fraction button there, and it stays the same, so our fraction is reduced. So this will be our final answer. All right? One more. I would recommend you guys pause this, try to do it, and then go ahead and come back and check your answer. Okay. All right, hopefully you paused it. Let's go ahead and try this. All right, let's put it all together now. So when we look at this one, we've got a power on the outside. That power doesn't apply to everything in the problem. This power only applies to what's in parentheses, which is this stuff right here. So the 6ab to the third, which is on the bottom here, this does not have a power to it because it's not in the parentheses. So let's go ahead and apply just the first part here, that 2, to everything on the top. So we're going to have 3 to the second, a to the 5th, raised to the second, b to the 4th, raised to the second. So everything on the top got that 2 applied to it. On the bottom, we've still got a 6, we've got just one A right there. And then we've got three B's. Okay? So now let's try to simplify this and see what happens. On the top part, we end up with a 9 and a 6. Simplify further, we got 10 A's and 1 A. For the B's, we got B to the 8th and B to the 3rd. Okay, so we distributed, we're almost there. Now let's go ahead and simplify these. Okay, 9 over 6, you can throw it in the calculator, is going to give us a 3 over 2. With the 10 and the 1, 10 minus 1 means that we're going to end up with a 9. And with the B's, we've got 8 minus 3, which is going to leave us with a 5. That's it. That's the entire problem. Remember when you're doing these to try to go step by step and try to maintain the same steps. Distribute if possible. Do one thing at a time. I know that you could do this, okay? You take care and have a great day.